Hello and welcome back, everyone, to the second episode of the Brain Power Podcast. If you are returning from our first one, then we are happy to have you back. I am your host, Maxwell Hand, and this podcast is going to be all about what TMS is and how it works. A fair warning, though, this will get very technical and quite nerdy, but don't worry, that's kind of how I roll. So, on that wonderful joke, we're going to go into what TMS stands for. TMS stands for Transcranial Magnetic Stimulation, and I think breaking down the name will be a good introduction to what the technology is and kind of how it works. So, transcranial. That's going to mean across or through your head. One thing that allows this technology to work is that it can induce changes in your brain across your skull. So, there is no surgical procedure needed. It's completely non-invasive, and what happens is a coil is gently placed on the surface of your head, and the stimulation begins. There are no electrodes involved, and it's a very friendly and nice treatment, to be honest. Next, we have magnetic. Now, the mechanism of action of TMS is called electromagnetic induction. And a background on this is this scientist named Michael Faraday discovered this interesting effect in 1831, and it was aptly coined Faraday's law of induction. And this law of induction stated that a changing magnetic field is able to induce an electric current across a solid structure. Now, it's really cool about this. We don't have to perform inner surgery. We're able to do the procedure or the stimulation without any invasive techniques. And what these creates are these things called electromagnetic waves. And these waves are very accurate, yet very weak. So they can be used to alter the electrical activity of your brain. And that's the background of why it's called magnetic. Now, the final word is stimulation. Stimulation has to do with the interaction between the TMS coil and the electrophysiology of the brain. Now, electrophysiology is a big word for saying the way that your brain communicates to each other. Different brain regions have to have a way to signal each other about what's happening, and so they use short bursts of electricity. This form of communication in your different brain regions is very similar to TMS, and so we're able to piggyback off this effect in order to target either underactive or overactive nerve cells. This is because we are able to add electrical signals in order to alter the function of the human brain. In this way, we can create chemical and structural changes in nervous cells over a 4 to 6 week stimulation period. Now, that kind of covered the beginning of what TMS is and what it stands for. Hopefully that shines some light on the general idea behind it. And we can move forward by looking at some of the applications that TMS is used for. So in the recent couple of decades, TMS has been given a huge spotlight in the world of mental health therapy. The emphasis on research and the number of clinics and hospitals which use this technology have really increased a lot. So this means there's going to be more research coming out on the safety and the effectiveness of this really wonderful treatment. There is a growing interest in the world of TMS and the many applications that it can be used for. So, on a quick tangent, but I think very interesting, TMS is also used in pre-surgical mapping. This shows a different application compared to mental health therapy, but they are able to map the brain in a way that they can determine the function of very specialized brain regions. And this is helpful in neurosurgery because you want to make sure that you're not going to affect any very vital nerve cells around the area of surgery. And also it's going to help in a quicker and easier recovery for patients. In a very safe way, certain parts of the brain are essentially able to be turned on and off temporarily, and that's how they can determine what functions reside in certain brain regions. And this has really helped the world of brain surgery, as well as given us a much bigger view into our general understanding of brain functions and where they are located in the human brain. Now, I said before that TMS, you can turn the certain brain regions on and off, but it isn't as easy as that. It's not as easy as turning a machine on and off like a switch. There are several really important parameters that determine the resulting effect on the nervous cells. So one of the most crucial variables in TMS is going to be the frequency at which the coil pulses at. That's basically how many pulses are administered per second. And this is important because our clinic uses RTMS, or something called repetitive transcranial magnetic stimulation. And this application of TMS is able to use repeated stimulations over a specific brain region between 4 and 6 weeks, and this creates a longer lasting effect on the brain. And not just temporary. Most patients see a benefit in their cognitive abilities for multiple months or years beyond the treatment. And this application of TMS takes advantage of something cool in your brain called neuroplasticity. Now, neuroplasticity is our brain's way of learning and adapting over time. And so when we encounter a stimulus that we get repeatedly exposed to, our brain has a way of adapting and learning what that is. And we take advantage of that with TMS in order to help correct some of the shortcomings that people face with mental health. Getting back to how TMS is really performed and the protocols involved. Now, I mentioned that frequency is a very important thing. And what's cool about frequency is that depending on the level of frequency, you get different responses. It's mainly believed that a low frequency of 1 hertz or 1 pulse per second is going to have an inhibitory effect, meaning that it will decrease neuroactivity. And above 5 hertz frequency, anywhere from 5 hertz to 50 hertz, it's going to have an excitatory effect, meaning that it will actually increase neuroactivity. So common applications of TMS, like I said before, use frequencies anywhere between 1 hertz and 50 hertz, depending on what they are treating. Now, besides frequency, another key variable in TMS therapy is going to be the stimulation location. For the purposes of normal TMS coils, the brain regions which are able to be stimulated are actually very superficial. So the stimulation location has to be near the exterior of the cortex or your brain. The coil is not able to have an effect or a significant effect on more internal areas of your brain. So that's why one of the main regions people target for mental health therapy is going to be the DLPFC, or the dorsolateral prefrontal cortex. That's going to be the main location for depression, as well as a few other mental health therapies. While the DLPFC is located both on your left hemisphere and your right hemisphere, we actually only target the left side of it. And that's going to be on the very external part of your cortex. All right, folks, if you made it this far, I wanted to congratulate you. You're doing an amazing job, and we're learning a lot. I know it's been a lot of information to process, so now is a great time to take a little break if you guys like. All right, folks, assuming everyone's come back from their little break, their tea time, let's dive right back into it. Coming back to the parameters, the stimulation frequency and the stimulation location are not going to be the only variables that are very important. There are a lot of other parameters that are needed to perform this TMS protocol on any given patient, but they are all dependent on the actual disorder and dysfunction we're treating. So it's very personalized to each patient, and when someone comes into our clinic, we have them go through an assessment and we determine the best protocol for their individual case. So you can be assured that whatever you're going through, we are doing our best to personalize the treatment for the best results. Now, TMS is generally regarded as a safe and effective stimulation technique, but no treatment is perfect. So the last thing we want to cover in this podcast of how TMS works are the minor side effects you might experience. I think it's very important to cover it and be very open about this. There are not actually a lot of side effects associated with this. The main ones in TMS studies have been found to be minor headaches, tiredness, and facial twitches, typically experienced directly underneath where the coil is placed on your scalp. So I'll go through each three of these things and tell you a little about them. So the minor headaches are going to be easily remedied by over-the-counter medication. Usually they last between 1 to 2 hours after the treatment and go away naturally. But if there is any one that are lingering, you can take Tylenol or Advil, and that will go away really quickly. The tiredness comes from the external exertion of the brain. When you study for a really hard test or a really long time, you tend to feel a little tired because you've used so much energy in your brain. And that's the same thing that's happening after TMS treatment. We basically are activating the brain in a certain way that you're not used to. And so it's going to take a little bit more mental energy out. That's going to be remedied by a quick nap, but most people are able to return to their normal life right after treatment. The last thing will be the facial twitches. Now, those are going to be minor muscle spasms directly underneath the coil wherever it's placed. The typical stimulation locations are located over the forehead or behind the left temple. And so that's going to make your left eyebrow twitch a little bit, and it's going to make your left cheek twitch a very small amount. This only happens in patients who are at a very high level, so you'll only experience this, if not at all, for part of your treatment. And these facial twitches normally end right after the stimulation, just because it's associated directly with the pulsing. So TMS is pretty awesome. It's very safe, and it's been shown to be very effective in treating very difficult and persistent mental health issues. So that's why we really want to see TMS take off, and we want to do more of the research on it so we can help out as many people as possible. So that about wraps it up for how TMS works. I'm sure there's a lot more that could be covered, but it's been a lot for one podcast. Thank you for listening. You can find more information on our website at brainstemcenters.com. It was lovely to have you, and I hope you learned something today.